Hey everybody, this is Larry. This is day 20 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's problem. Binary search tree iterator. Okay, cool. So it seems like this is a week of my weakest stuff. So thanks for watching and thanks for kind of supporting me through the struggle. So there are definitely weak spots for me, and definitely binary search trees are kind of just stuff that doesn't really come up for me in competitive or regular programming, if you will, like professionally. So it is something that I'm a little bit out of practice, even though like I get the idea and I get the invariant, and hopefully it comes through in these videos. But that also doesn't mean that like like I struggle a little bit with the implementation. So we'll see how that goes. Anyway, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. And it seems like my my streak indicator is saying that I have. Oops, I clicked on the wrong button. Oh, that actually just took me back to this. 749 days. So this is my 750th day, which I don't know. It's just a round number, right? It's exciting, kind of. So let's go. Okay, implement BST iterator. I mean, I guess it is just what the title sounds like. Okay. So initiate the object, has next and next. So the cheese thing to do is probably just like put it into an array and then just see if it has the next object. I don't know if there's a. I mean, again, this is maybe another advertisement for the Morris traversal in that you can kind of maybe do that, but it's a little bit tricky in that you just suspend. You suspend the execution to the next iterator or something like that, one at a time, which I don't think is that hard, but I don't know. Like I said, I'm generally against Morris traversals, so yeah. I think one thing that we can do though is actually use a stack as a depth first search. It's been a long time since I've used a stack, so we'll see how that goes. But basically, the idea is to, recursion is, and I talk about this from time to time. Maybe probably not as much as I like, as much as I should, for recursion. But basically, recursion is pushing everything that you know of the current state onto a stack, and then kind of suspended while doing another thing, right? Which is we talk about core stacks and stuff like this in a lot of videos. So we just have to kind of do that explicitly instead of using recursion, and you know what they say, to learn recursion you have to learn recursion. So yeah. Okay, so let's play around with that idea and then we'll see where to go. Yeah, I actually don't haven't done this in a long time, so we're gonna have to discover it together. I'm just thinking about how to plan out the code a little bit. But yeah. And then maybe a code, because then now and next and has next should probably be pretty straightforward, or one of them is straightforward depending on how you do it. Yeah, and then the other one is a little bit trickier. So basically what we want to do, let's do has. So we want it to be in order, right? Just so that means that it is left, the current node, and then the right. Right? How do we do that? I don't even know, to be honest. It's been a while. Okay. Do I need a node? Okay. I mean, okay. So, sorry, friends. I'm trying to think about how to implement it in a clean way as well. Or not really, not even clean, just reasonably clean. So, okay. So basically, we're going to do in order, and then in order, the next is. Okay, so what is the current node? Do I need to keep track of the current node? Yeah, I guess so. So what I'm thinking of right now is, if you know, we have a, I guess maybe I could write it out. If we have a in order thing, it'll be, you know, process now, process, you know, node dot left, process node, process node dot right, right? Obviously, this is pseudocode, because otherwise this is just infinite loop. But something like that, right? And then here, the way that we would imitate that by, okay, we're starting at the root. Do I need an instant of the current node? I guess we need an instant of the current node just to maybe figure out how to would that be top though? Okay, so I'm just trying to think through my head what would the recursive stack would look like. So first, let's say we are the first element. Okay, and I'm just trying to think through in my head what would you do? No, what would the recursive stack look, or what would the invariant look like? And I think I was trying to think about it one node at a time, but I think in term before the invariant. And now that I'm thinking about the invariant, maybe it's a little bit cleaner to think about how do we maintain the invariant, right? And I don't know that I have that quite yet. This video is pretty long. This is 6 minutes of me saying nothing, so I apologize. Remember that you can always fast forward, watch it on 2x, whatever you need to do. But that means that we can keep on putting left on the so then, or like the first step, what would we do, right? We would effectively keep on putting the left node onto the thing, right? So yeah, so then the first thing we would do is, I don't know if I put that on the next or do it initially, but we can do that. No, let's put it in the initial. Maybe my mind will change, because this is definitely code that I haven't done in a while, or at least not in a non-cheese way. So yeah. Okay, so let's say, you know, I don't know if this is needed per se then, but okay, so then, okay, current is equal to sub.root, or just root, while okay, so then now we go to the leftmost node down the tree, and that would be where we have the first item. So, oh, actually, this is a little bit wrong. What we want to do is actually maybe push to the stack current dot value, right? Okay. And then now, what does this mean? That means that stack will contain all the current dot value. Oh, I think maybe we should keep the node. Maybe that's a little bit easier. We probably don't have to do that, but or we would have to use some tuple or something to keep track of it anyway. So yeah, and then now, what does next look like now? If the invariant is such that we have all the left nodes, one is to so let's say we have all the left nodes on the tree, and I'm just kind of visualizing in my head. Maybe I could do some. I don't really have a easy drawing setup, but now we have all the left nodes. So that means that the first next would be the stack of this one, right? So then now, yeah. So by definition, then we do okay. So return value is equal to self.stack to -1 the dot value, so we return this. Has next would just be, I guess this would just be return whether length of self.stack is greater than 0, maybe. I don't know if this is true actually, so don't quote me on that yet. Okay, so now let's say we have this value and we popped it, right? And this is the leftmost. So technically, now for the node's current context, now you want to push to the right, right? So then now we go maybe something like this, where let me actually rewrite this a little bit. So node is equal to this. RYU is equal to node.RYU, and we return that, that's fine. And then now if node.write is not none, then what do we want to do? So then we process this node. So now we want to process the write node. So then node is equal to node.write, and then I think now we do this thing, the same thing that we have here where we process all the left. So then now maybe I'm thinking of adding a helper function. I guess this void is fine, right? I don't know if this is, I forget. I don't remember the type hint stuff because it's still new to me. So yeah, so then here we can be node, right? So then here we can do something like, I don't even think we need root in this case anymore, except for saying solve that. I may be wrong on that one though, so we'll see. Current is equal to node, right? Yeah, and then now we can change this to node.write, right? Something like that. And I want to say this is okay. And also, this may be off by one actually, because I'm doing current.left is not none, but then I'm pushing this thing. So so I think what I want, I think I also want to add this. Maybe this is right. Well, let's give this a quick spin just to kind of see where we're at. Okay, we're really wrong, but wait, are we? We're definitely very wrong because we keep on. What is the tree? Oh, this is the tree, and I return 7. That is a little bit awkward because okay, so current.left is none. Oh, I think this is what I mean. Maybe this is. I think I got confused myself a little bit. Okay, because we didn't get rid. So the way that I debugged that was that I was like, oh, we didn't process the 3, so we definitely need to process the 3. Okay, so this is slightly better. But obviously, I don't know if it's slightly better actually, but it is different. We do have the 3, which is our goal for that one. Okay. Oh, I didn't pop. That's why. So yeah. Yeah. So now we pop this because we're done with this node, and then we process the write, which we processed. Yeah, it's almost like we're getting the next node to be processed, which is maybe that's a better way of phrasing it. The next node to be processed is going to be the leftmost tree, or leftmost node of the thing. Let me give it a submit real quick. I might be wrong on this one, or like there's an edge case that I'm wrong. Oh, okay, cool. I'm really happy about this actually, because I'm not quite sure what the canonical solution for this is, or like what's the quote clean way. So this is something that if you're watching now, I am solving this live. Like this is from my own head. I actually don't have this is not from maybe it's a little bit from experience. I don't know, but this is definitely the first time I've done this in a long time. Maybe I lied. Maybe I look at this code and it's like, nope, Larry did it this other way. Oh, I guess I lied because I didn't have the thing, but I didn't have a helper, but this is essentially the same thing that I just did. Okay, so I did lie a little bit. I don't remember this at all though, to be honest though. So I feel like for me, I solved it I'm doing this a new cool way. But I think the visualization is a little bit tricky, so I maybe want to explain that a little bit. But the idea is that okay, in order, right? It's left, now, right. So that means that when you have a node, we process all the left that we can. That means that in the context, or like if you kind of get into the mind of a node on the context of that node, that means that all the left is done, right? That means that when we go back, this node, the current node, is the one that we're processing, and this is what we're doing here. We're processing this current node, and then after we finish, which is while we pop, we recursively go to the right. And in going to the right, then in kind of context of the next right node, you have all these left nodes that you have to process in that recursion stack. And that's basically the idea that I have. So what is the complexity here, right? So I think one thing that you may be fooled a little bit, maybe, doesn't have to be you, is that you have this while loop. While loop every time is just O of n every time. The question is, there is some amortized analysis, right? That means that for every node, obviously, you're only going to put it into the stack once, and you're only going to pop it once. So in that sense, if you amortize it over the entire tree, this is going to be O of 1 amortized per next, and O of 1 amortized per hash. Well, this is just O of 1, not amortized, but O of 1 amortized for next, even though this can take up the O of n or O of h of the per core, right? Of one core could take O of h, but then that's it, because everything's amortized. So in total, we're going to look at each node once, or O of 1 time. So it's going to be linear time, linear space, or O of h space if you want to be more specific. And from that, I'm not going to go over the O of h space that much today, just because I think if you've been doing this for 6-7 days, that's pretty yeah, like we've been talking about it. But yeah, even though apparently I did the same thing this last time, hopefully this was a good like visualization of how I attack a problem, because I definitely do not remember the invariant that solves this problem. I mean, I remember the BST invariant, and then you kind of saw me do the kind of sketch out in order, and then thinking about what that means and having an amortized algorithm. So yeah, let me know what you think. I hope y'all have a great rest of the week. Man, I'm still a little bit sleepy. I took a nap, so today maybe it's a little sluggish. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. And of course, stay good, stay healthy, to good mental health. I'll see you later. Take care of yourself. Hopefully, if you have a chance, take care of others. I'll see you later. Bye-bye.